we're factoring review again on this section. It says in Unit 10 we will be simplifying and performing operations to rational expressions. So rational expressions are fractions that have like x's in them. Okay? So it says in order to simplify rational expressions, you must remember how to factor. And that is because when you are dividing, you can only factors cancel out. And what we mean by that is if I had 3 times 4 divided by 3, factors again are separated by multiplication. So since that's separated by multiplication, I could cancel the 3's out, and this is just equal to 4. And remember, if you don't believe that, 3 times 4 is 12, 12 divided by 3 is 4. So the shortcut is just canceling those factors of 3 out. That's the most elementary version. What we're going to be seeing a lot of are ones with variables in it. So if we see like x minus 2 times x minus 4 over x minus 4, since there's multiplication right there, those are factored. So if you have the same factor on the top as on the bottom, then you can cancel it out. So in this case, I have an x minus 4 factor on the top and an x minus 4 factor on the bottom. So those would cancel, and then this would just be equal to x minus 2. Okay, so that's the whole reason why we need to factor, because we can cancel factors out. What you can't do is you cannot cancel terms. So if I had 3 plus 4 divided by 3, that 3 and the 4 is separate by addition, so I can't cancel the 3's out there. Because this is going to be equal to 7/3. So if you cancel the 3's out, you get 4, which is not the correct answer. In regards to kind of what we're going to be doing, if we had x squared plus 2x minus 7, and I had x squared on the bottom, again, that's separated by addition, so it's not a factor, so I can't cancel the x squareds out. I have to just leave it as is. There's nothing else I can do there. All right, so that's the reason why we need to review our factoring. And again, here are our factoring methods. So remember, the first thing we always look for is we always look for a GCF, or greatest common factor. Okay? And so you always look to pull out a GCF first. And when we're looking for a GCF, you want to find the largest number and or variable that is in common in all the terms. And once you know what that common variable and or number is, you're going to make one set of parentheses, put that GCF in front of the parentheses, and then you divide each of the terms by the GCF to determine what is inside the parentheses. So again, this should not be new to you. This is a review day, basically. Notice things we have done. Sometimes it has been a little while, but it's not new. All right, so if we look at 25x cubed plus 75x squared, the first thing we're doing is we're saying, all right, what is the largest number and or variable that goes into both of those terms there? 25 is a number, and what else do they both have in regards to a variable? X. They don't have at least x to what power? X to the second. So 25x squared is our GCF. We're making one set of parentheses in. The GCF's in front of it. And to see what's going inside, we divide each of our terms by the GCF. So 25 divided by 25 is 1. What's x cubed divided by x squared is just x. So we subtract those x. We subtract the exponents. And then 75 divided by 25 is 3. The x squareds cancel out. This should be done. Remember, you could always double check your work even if you don't write it down. Just do a quick distributive property. 25x squared times x is 25x cubed, which is what we start with. 25x squared times 3 is 75x squared.
Why is it stop with the first one?
Right here,
Mhm.
25 divided by 25 is 1.
Yeah.
So there's really a 1x in front of it.
It would be 25x.
That's our GCF. This is our
Oh.
GCF. That's the factor that can divide into both of our terms. I can divide each of the numbers by 25 and get a whole number out, and I can divide each of them. They all have at least x to the second power.
Oh, okay, so you put the GCF in front and then you put the parentheses around it. Yeah.
Yeah. And then whatever is left after you divide.
Yeah.
This is on the side. All right, for example 2, we're looking for, again, the largest number and or variable that goes into both terms. So 3 is the number, they both have at least an x. So 3x is the GCF, we're putting it in front of the parentheses, and we divide everything by 3x then. 6 divided by 3 is 2, x squared divided by x is just x. 9x divided by 3x is just the x's cancel. Again, if we did a quick double take or double check with distributive property, 3x times 2x is 6x squared, 3x times 3 is 9x. All right, try 3 and 4 on your own. GCF is 2. Remember, put the GCF in front, divide everything by the GCF, which is 2. You get 7y squared plus 9. What's your GCF for number 4? XY. There is no number that divides because there's just a 1 here. But they all have at least x to the first, and they all have at least y to the first. So you divide everything by xy. X squared divided by x is just x. Y's cancel. 2 divided by 1 is 2. X's cancel, and then y.
See, I told you.
Okay, so that is your GCF.
I said there was a 2.
Alright, next option for factoring then is difference of two perfect squares. And if you look on page 3 of your notes, we have that flow chart that we did before. So remember, it says we factor out a GCF first. I'll go back to this. We have to factor out our GCF first always, that's why that's the first thing we want to. And then if there's still 2 terms, our option is difference of squares. Okay? Or not factorable further. So with difference of squares, first thing is only 2 terms. Both of those terms have to be perfect squares. Remember, perfect squares are things like 2 times 2 is 4. 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. 5 times 5 is 25 is a perfect square. X times x is x squared, so x squared is a perfect square. Y times y is y squared, so that's a perfect square. Okay? So both of them have to be perfect squares, and difference means what operation? Subtraction. So the terms have to be subtracted also for this to work. So our formula is you're taking a perfect square minus a perfect square, and you're making it into 2 terms, or 2 sets of parentheses. This is like reverse, this is kind of like SAM actually. And you take the square root of the first, which is going to be a, and then the square root of the second, and they always have opposite signs. Square root first term, square root second term, and then you opposite signs. So we do always want to look for a GCF first. There is no GCF in 25x squared and 9. And if we go through our flow chart, then there's two terms. Look here, they're being subtracted, and they're both perfect squares. 25 is a perfect square, so is x squared, so is 9. So we're going to make our two sets of parentheses. Take the square root of 25x squared, which is going to be what? 5x. So that's going in the first part of our parentheses. We're going to take the square root of 9, which is 3. And then we always have one positive and one negative. It could be 5x minus 3 times 5x plus 3. That's fine. But the 5x has to be positive. And then for example 2, same thing. There's no GCF. There's two terms. They are being subtracted. X squared is a perfect square, and so is 81. So again, we're going to take the square root of x squared, which is x, square root of 81, which is 9, and then one positive and one negative. So go ahead and try 3 and 4. All right, so again, all of these are going to be the same. There's no GCF for any of these, so they're all going to just be difference of squares. So we have 2x and 2x plus 7 minus 7. 2x plus 7, 2x minus 7 will be our answer. Same thing here. Square root of 9x squared is 3x. The square root of 16 is 4. Again, one positive, one negative. All right, turn to the next page then. Page 2. So, again, if we look at our flow chart, we made it to the factor out of GCF. There were two terms. We saw a difference of squares option. Sometimes it's not factorable at all any further, and that's okay. And now we're going to start looking on this three-term side. So we spent a lot of time SAM factoring, and we SAM factored last chapter, so that should be familiar to us. SAM factor, remember, is when there's three terms and there's a 1 in the front of our x squared. So remember, SAM factor means what multiplies to the last term and adds to the middle term. So you're going to make two sets of parentheses that are being multiplied together. So here, example 1, we look for a GCF. There is none. We notice there's three terms, so we're going to the right of that flow chart. There's a 1 in front, so we can write our acronym of SAM over top of it. We make two sets of parentheses, and then we say what multiplies to x squared, which is always x times x. And then we're saying what multiplies to the last term and adds to the middle term. That's why we have the A and the M where they are. So multiplies to 8 and adds to 6, 2 and 4, and they both have to be positive. 2 times 4 is positive 8, 2 plus 4 is positive 6. For example 2, again, you look for a GCF first. There is no GCF. We have three terms with a 1 in front, so we are going to write our SAM. And we're saying x times x gives us x squared. And now we're saying what multiplies to negative 6 and adds to negative 1. Three, 2, and negative 3, positive 2. Again, negative 3 plus 2 is negative 1. Whatever that sign is, there's always going to be the sign of your larger number. All right, try example 3 and 4. Number 3, there is no GCF, so you are doing SAM factoring. Multiplies to x squared is x and x, so we're saying what multiplies to 2 and adds to 3. 2 and 1, and they both would be positive. Now, for example 4, again, we said we always look for a GCF first. What divides into all three of those terms? 5. So we're pulling out a GCF of 5. So we'd be left with on the inside x squared minus 1x minus 2. Now we can Sam factor that. And again, looking at our flow chart, we look for a GCF first. We pull that out. There's 3 terms. And now when we look inside, there's a 1 in front of that coefficient. So it's taking us there. So the 5 just stays in front. We make our 2 sets of parentheses. X times x gets us to x squared. What's the only thing that multiplies to 2? 2 and 1, and then yes, it'd be positive 1 and negative 2. Negative 2 plus 1 is negative 1. All right, our last little review part is what happens when we look for a GCF. There's 3 terms, and we still have a number in front of our x squared that's greater than 1. And that's our slide divide bottoms up method. We have not done this for a little while, so we might want to quick review it. All right. So when we have 3 terms and there's still a number in front of the x squared that's larger than 1, kind of like example 1 here, there's no GCF, and we have a number larger than 1 in front, we're going to do that slide divide bottoms up method. And step 1 is we're going to slide and multiply the a coefficient. Remember that a is what's in front of the x squared, and the c. So we're going to take that number in the very front and multiply it with the number at the end. You're writing the product in place of c. So I'm taking the 7, multiplying it by 4. That's our sliding it over. So we get x squared plus 29x plus 28. 7 times 4 is 28. The reason we're doing that is because now that we slid that over, we have a 1 in front of our x squared. So guess what we can factor that with? Sam. So we can factor the remaining expression using Sam. All right, so we're saying what multiplies to 28 and adds to 29. One and 28, both positive in this case. Now, the thing that I have to warn you about, and I warn it every time, is you can't just stop here, because if you FOIL this, you get this step, but you don't get what you originally start with. We want to get what we originally start with. So that's why you have to do all 3. Slide, divide, bottoms up. Slide, divide, bottoms up. You guys remember that song? Should I play it again?
No.
Yeah. It's a good one. All right, so we have to divide. So we're going to divide the second term of each factor by the a. And we reduce the fractions. So the second term of each factor are the numbers. So I'm going to divide the 1 by 7, because that's what I slid over. Divide 28 by 7. We reduce what we can reduce. 28 divided by 7 is equal to what? 4. I can't reduce 1/7, so this is where I do the bottoms up. So bottoms up is move any denominator to the front term of the factor. So this 7 moves out in front of the x. So I get 7x plus 1. Doing a quick FOIL check, even if it's just the first and last, 7x times x gives us 7x squared. 1 times 4 gives us 4. So we're most likely good. Try example 3 on your own. Just do 3. So you will have to do slide, divide, bottoms up, slide it over, Sam factor, and then you're dividing by what you slid over. So there is no GCF. There's 3 terms. We have a number larger than 1 in front, so we are going to slide, divide, bottoms up. So we get minus 10 at the end. And when we Sam factor that, we'd be saying what multiplies to negative 10 and adds to positive 9. Good. Positive 10, negative 1. We then divide by what we slid over, which is a 2. We reduce what we can. 10 divided by 2 is 5. 1/2 I can't reduce, so that's where I'm doing bottoms up. So I get 2x minus 1. Quick little check. X times 2x is 2x squared. 5 times -1 is -5.